Welcome to the deep dive. Today, we're looking into something pretty cool. Running large language models, LLMs, right there on your own machine.
Yeah, your own computer.
If you've been curious about playing with AI, but, without relying on cloud services all the time, this one's definitely for you.
Exactly.
Yeah.
We've got this great source, a blog post called Setting Up Ollama Locally, Part 12 Notes on AI. And it's not just a dry how-to.
No.
It's someone's actual journey. They hit some roadblocks, found some smart workarounds. It feels really practical.
Right. So our mission today is basically to unpack that experience. We want to understand the steps for setting up Ollama. That's the tool they used, figure out the hurdles they faced, and see what that first interaction with a local AI model was actually like.
Yeah, get a feel for the nitty-gritty. See if it's something you might want to tackle yourself.
Okay, so let's dive in. The author kicks things off with a problem I think many of us know too well: running out of hard drive space.
Oh, yeah. That's almost step zero when you start downloading big models or data sets, right?
Totally. And the first thought is, okay, gotta buy a bigger drive. Seems logical.
It does. But this is where it gets interesting. Instead of just, upgrading the hardware straight away, the author found this console tool called DUA.
DUA.
Okay, what does that do?
It basically just scans your drive and tells you exactly where all the space is going, like which folders are the biggest culprits.
And wow, did it make a difference here?
Yeah.
The post says they went from like 98% full, which is panic territory,
Yeah, definitely.
down to 58% full just by using this tool.
It's a huge recovery. And it wasn't anything super complex either. The main space hogs, things like orphaned Docker containers, and get this, tons of old Python virtual environments.
Ah, yes. The virtual environment graveyard. We've all got one.
Exactly. And they just sit there eating up space. The author even showed the DFH output before and after, clear as day. And the DUA tail command pointed to things like .config, .cache, .pnv, .local, adding up to nearly 70 gigs just in the top few.
That's wild. It really shows how much digital detritus could build up without you noticing. It does. And there's a useful tip in there too. Use do-ii. That's the interactive mode.
Right, so you can tag multiple folders and zap them all at once.
Apparently so. Sounds much quicker than deleting one by one.
Okay, so disk space crisis averted. Now they could actually get to installing Ollama. How did that go?
Pretty standard command line affair, it looks like.
Yeah.
They used curl to download the compressed file. The .tgz file.
Right. curl-l https://ollama.com/download ollama-linux amd64.tgz ollama-amd64.tgz. Yep.
And then tar to extract it. Sudo tar
They
cyan
just-
ollama-xdf ollama-linux amd64.tgz.
Yeah. So it got unpacked into their home bin directory.
Okay, straightforward enough. But the author did mention wishing for a DEB package,
Yeah, that came up.
which makes sense if you're on Ubuntu or Debian. Makes updates and removal a bit cleaner usually. It's a fair point about user experience.
It is. Distributing via tarball like this is common for cross-district compatibility, especially for dev tools, but yeah, package managers are convenient.
So Ollama's installed. The next logical step is fire it up. Exactly. Run Ollama surf just to see what happens. Check the initial logs. The author points out, and it's a good point, that these first logs are super important.
Right, they tell you if it's even working, if anything's missing, if it detects your hardware correctly,
Right.
all that jazz.
And the logs here were quite revealing. First, some standard stuff. Generating a new SSH key.
Okay, security housekeeping.
Then confirming it's listening on the local port, 11 port 334. And then it starts looking for GPUs.
Ah, the crucial part for performance. Because running these models on a GPU is way faster than the CPU, right? That's the inference speed thing.
Generally, yes.
Yeah.
Hugely faster if the GPU is supported. And that's where the warnings popped up in the logs.
What did they say?
There were messages like, Ollama recommends running the official AMD drivers, and that a specific version file was missing.
Okay. Driver issues, maybe?
Sort of. Then came the key lines. AMD GPU, too old GFS 803. And then, no compatible AMD GPU devices detected.
Ouch. So the GPU is just too old.
Seems so. The author confirmed it with else ABI. It was an AMD Radeon RX 400 or 500 series card. Ellesmere architecture.
Okay, so not ancient, but maybe not new enough for Ollama-specific requirements for acceleration at that time?
Apparently not. So the consequence, the log confirms it later. Inference compute, ideal libraries, BPU, it fell back to using the CPU.
Right. And it also shows the available RAM, about 6.2 GB free out of 15 total. So CPU bound and kind of limited on RAM, that definitely impacts what you can run.
Absolutely. Running on the CPU is possible, especially for smaller models, but it's going to be noticeably slower. You type a question, you wait longer for the answer. sometimes significantly longer.
Okay, so faced with that reality, no GPU help, limited RAM, what did the author do next?
They did something pretty smart, actually. They took those log entries and fed them to an AI chatbot.
Huh. Using AI to troubleshoot AI, I love it.
It's meta.
Yeah.
And the chatbot gave some sensible advice. Start small. Try models like Tiny Llama or Gemma 2B.
Because they're less demanding.
Exactly. They have fewer parameters, need less RAM, and are more likely to give a usable, if not super fast experience on a CPU-only setup with around 6 gigs of RAM available. It's about matching the model to the hardware you actually have.
Makes perfect sense. Pragmatic. So they decided to go with Gemma 2B. How did they pull that down?
Simple command, Ollama run gemma.2b. That tells Ollama to download the model if it's not there locally, and then start an interactive session with it.
And they checked its stats first?
Yep, using the show info command within that session.
What did that reveal? Anything interesting?
It confirmed the basics. Architecture, Gemma. Parameters, 2.5 billion, which is relatively small in the LLM world. Context length, 880192.
Okay.
And it mentioned Q40 quantization.
Ah, quantization. That's the trick to make models smaller and run faster, right? By using less precision for the numbers.
Gist of it, yeah. Reduces the memory footprint and computation needed, often with only a small hit to quality, especially for smaller models. It's pretty crucial for running things locally on consumer hardware.
Gotcha. So Q40 is one type of that. And the license.
Gemma, terms of use. Standard stuff for that model.
Okay, moment of truth time. Did it work? Did they ask it something?
They did. Kept it simple. What is 1 plus 1?
The classic test. And the response.
It came back with, sure, 1 plus 1 is equal to 2. It is the sum of two numbers, 1 and 1.
A little verbose maybe, but correct.
Correct. And more importantly, it worked. Even on the CPU, even with the older hardware. That's the win. Ollama was running, the model was loaded, it processed input, generated output. Success.
That first successful interaction, even if it's simple, feels like a big step.
It absolutely is. It proves the core setup is functional. And the author notes that the next plan is to look at different front ends or interfaces to talk to this local Ollama server, which, opens up way more possibilities than just the basic command line.
Right. So let's just quickly walk back through what we saw today. We started with a very real problem of disk space and the clever use of the Duo tool to fix it without buying hardware.
Yeah, finding nearly 40 gigs back. Impressive.
Then the straightforward Ollama install using curl and tar, followed by firing up the server and digging into those initial logs.
Which immediately highlighted the GPU issue, the Radeon card being too old for acceleration.
Leading to the fallback to CPU processing, confirmed in the logs, along with the available RAM.
And that, in turn, led to the smart decision, aided by another AI, to start with a smaller model like Gemma 2B.
Which they successfully downloaded and ran, getting that first basic 1 plus 1 answer. It's a great little case study in practical problem solving.
It really is. It shows that while jumping into local AI isn't always plug and play, and you might hit hardware limits, you can often still get things working with the right approach and tools. You just need to manage expectations, maybe start smaller.
Absolutely. And for you listening, this whole process brings up an interesting thought. Even with limitations like an older GPU forcing CPU use like we saw here, what could you do with a language model running entirely locally on your own machine?
What kinds of creative tasks or maybe productivity helpers could you experiment with knowing your data isn't leaving your computer?
It definitely opens up possibilities for personal AI projects away from the big cloud platforms. Something to think about.